find the general solution of this differential equation here. So we got dy by dx minus y over x equals 5x. If we spend a little bit of time, we can rewrite this. dy by dx, I prefer to write it as y prime. And then we can separate. Instead of minus, so we can get minus, we can get 1 over x times y equals 5x. And when we see it like this, this looks more like a linear differential equation. It's not yet, or it's not written like the standard form of a linear differential equation, because we need a little plus sign here. But that's a pretty easy fix. Just move the minus into the p of x, the coefficient function. Okay? And when we do that, we see, hey, this is a linear differential equation, which has a particular way to be solved. Right? It has a particular form for its general solution. And you say, well, how did you know it was linear? Well, normally you'd play around with your differential equations, and you try and spy, well, what form of what class of differential equation do I notice that this looks like? Right? And in this case, yeah, it's linear. Right? So, if you're trying to solve a linear DE, so the one we have written in its nice, standard, correct, proper, elegant form, looks like this. If you're trying to solve a linear DE, and you've got it looking like it should, okay, the general solution can be pretty quickly found as the integral of mu of x, q of x, all divided. So once you're done integrating, you divide by mu of x. And what's this mu of x here? This is our integrating factor. And specifically, it looks like e to some antiderivative of this p of x, which is why the plus sign is so important. Cannot overstate that. Cannot say it enough. So in this case, what's our p of x? What's our q of x? And what will our integrating factor be? So our p of x here is minus 1 over x. Not 1 over x, minus 1 over x. Here's our q of x. And then we do need still our integrating factor. So in this case, it'll be e to, then we need an antiderivative. So we can pull the minus sign out. Integrals of 1 over x. We'll be looking at ln. Oh, but oops, don't need that d of x there. But e and ln cancel each other out. So it's actually going to look like x to the minus 1. 1 over x is going to be our integrating factor here. 1 over x. Okay. So there we go. All right, so p of x in this case, minus 1 over x. Q of x in this case, 5x. Mu, our integrating factor, is 1 over x squared. No, sorry, not 1 over x. I'm already sort of multiplying things in my head. It's just 1 over x. So they mean. Okay, so our general solution, which is what all we're asked for in this question, is going to be the integral of, you take your mu of x times your q of x, and you will divide by mu of x. So the 1 over x and the x here cancel out. Okay, we're trying to integrate 5. Well, you get 5x plus c. As soon as you're done integrating, add in that plus c. And you're dividing it by 1 over x. Dividing by a reciprocal of a number is the same as multiplying by that number. So we can actually distribute this 5 in here. And our final answer is going to be y is 5x squared plus some linear term with no constant term. There it is. So for different choices of c, you'll get different specific solutions to this differential equation. But we were only asked in this problem for the general solution.